Okay, we're ready to get started again. Our next speaker is Mr. Joaquin Ramirez.
Thank you, Tom. So I'm going to check timing. So good morning, everybody. Really excited to be part of the first conference that organized together with the Paco Foundation and the International Association of Wildland Fire here in Spain is really amazing. So, and especially the safety one, which has, so significant impact to our community. My presentation, my name is Joaquin Ramirez. I'm leading a company called Tecno Silva. Talk about a little about that, and I'm going to talk about one kind of modeling that we are developed, trying to support what we call the situation units, the redefinition of the situation units, the 2.0 situation unit, how the situation unit has to evolve within the needs to evolve, taking into account the advances that we have in observation, in computing, and the advances that we have in the professional community that really needs to face fires as it is happening right now in Chile, worst fire season in the history, 550,000 hectares, just right now, 3 times more, the worst year in the history, and how to support the operations in the field, how we can take all this modeling, science, and observations. So this is an example of an application of that, but I put a little background. As I said, I'm leading a company, also part of the Wildfire Masters program that we have in Spain. I'm leading a class on geotechnologies and wildfires. My company is called Tecno Silva. We based here in Spain. We moved to the US 5 years ago. We've been 20 years just working on wildfire and technology. That's what we've done. Wildfire and technology, I would say that wildfire technology and tools, because in the end, technology is out there, but what you guys really need are tools, okay? We have 3 tools that we have been working in the last 20 years with the support of the community. One is called Fire Response. It's an incident tracking and management system that is in place right now in several agencies, we'll see. The other one was developed, that we developed is an operational modeling tool called Wildfire Analysis. It was developed working hand by hand with the analyst teams in Spain, especially Marc Casteno from the graphs, people from Andalusia, I see my friend Rafael Gebra over there, people from Castilla-La Mancha, getting that experience that the analyst units were developing in Spain. We tried to create a tool for them. It's a wildfire modeling tool. And the final tool that we are creating, that's right now, that's the one that I'm going to show you how it's applied. It's called the tactical analysis. How managing incidents, understanding the fire, and now how to manage one incident. And we'll show the application, the mobility mode applicated here. Okay? So technology, as I said, growing. It's overwhelming. We see examples all over the place. I recently went to Las Vegas to see what was possible. And, okay, think about what's possible, erase it, and jump like 10 years in future. That 10 years in future is right now, okay? Virtual reality for training, sensoring our firefighters, sensoring the fire environment. That is possible in terms of technology, but we have to make it tools to really support the missions. So right now we're working with, in the US, we're working with all these units, with all these agencies, the Texas A&M, Forest Service, Virginia, several states are using what we developed in Spain here 20 years ago, the Fire Response. And some federal agencies like the Missoula Fire Lab, we are really proud, very proud of being working to Brett Butler on the development on the new safety zone, the Cleveland National Forest working on the definition of the new WE standards, or the Marine Corps in Camp Pendleton. In terms of the pirate industry, we're working with the NFPA and San Diego Gas and Electric to try to mitigate the risk coming from the electric utilities. And of course, in international agencies, we just implemented yesterday the first version of our systems in British Columbia. Chile is working right now with the tool that we're developing here, and of course, all the several agencies that we have here, okay? So in the end, moving from technology to tools, you have to take all the bells and whistles that are over there and try to do things that do the job, that are reliable, that are easy to use, easy to learn, okay? That provide solutions and answers on time, and that are affordable, okay? And after 1 week after, in the aftermath of the Yarnell tragedy, Tim Sexton, who is leading the research and development and application program for the US Forest Service, said that in future, that's 2013, we will see in the common post people being tracked with the GPS receiver, the current spread of the fire, and we will also have access to information like the calculated safe zones, okay? Well, the future is now. That is possible. That is what I'm going to show here. And definitely trying to face fires without this basic information is something that, honestly, I don't think the society is able to accept that we're facing that mission without this kind of basic things, okay? So in terms of, we know a lot of paella here in Spain, and it's all about integration, okay? It's the integration of the different capabilities, that the different tools that are out there provide us and really being served in the plate of the incident commander in the way that they can really understand and they can really be useful and transferred to the units on the field. So from the strategical level to the tactical level and then to the operational level for the people on the field. So that's the challenge. So Fire Response is the tool that we created to track the incidents in real time, tracking the incidents, tracking the units. This is an example on Virginia, where the fire is, what is the values at risk, the weather, all of that. That's at the dispatching center level, okay? Then you have to be able to share it in any kind of platform. And of course, the most important one, and I have a poster about this, and the most exciting one is put it on the information to the people on the field through the mobile technology. And on mobile technology, I can talk about there. So being able to provide intel and computation and observation and communication in the hand of the people that is taking the decisions is available right now, okay? No challenge of communication right now, nothing like that. The other thing is okay, what about the fire? And there's a lot of efforts of this very young science on trying to predict wildfire behavior. So, okay, know your enemy to better adapt to what can be possible in terms of decisions. So we have worked a lot on that. We don't build models, but we make models operational. So what I call it is our black magic is right now we're modeling fire with the Wildfire Analysis. The last implementation that we've done for San Diego Gas and Electric, we're making about 22 million simulations an hour. That's the kind of analysis or computing power that can be applied right now to take those decisions, okay? I have a model example. So that is, obviously, that is done with supercomputer, but this is not done in supercomputer. I think that hopefully you can see the video here, and we have it over there. Right now, on a regular computer, we can simulate fires, about 50 fires a second. That's basically. And of course, integrating, as you can see here, these are weather stations coming from San Diego County, real time. This is the interpolated 3D wind. So this scenario is everything in 4 dimensions. It's in the wind is coming from the weather stations, okay? Then we have the high-resolution wind that is affected by the measurement of the weather station. And now we can have people on the field with a small device that can tell us with a small weather station and tell us, okay, the local effect that is not captured by this station, as I just edited here, I just edited that wind. And now my modeling and my simulation is done in real time, taking into account into that, okay? We do that in applying the optimization of the Rothermel models, but we are using in Chile, we're using the Kitral model. That's what they're doing right now. This is an interpolation of the convection effect of the wind, so you can see it. And these simulations are calibrated on the fly. So the unit tells me that the fire got here, it's on the fly calibrated and tell us the adjusted rate of spread and the adjusted simulation for that fire on the Rothermel equation. That everything is about 5 seconds. So as I was saying, I think that there is a need to redefine our situation units. We have a really pretty good understanding, and it was something that everything in Catalonia. Mark was telling me, okay, you know, Joaquin, today it was 20 years that I took a plane to go to the US. I said, wow, a lot of things changed because of that travel, okay? After that, I think the graph units are gonna be 20 years in 2019, okay? So the graph units, define all the analysis techniques of the design fires based on past fire behavior, the weather, the fuels, and so on, define those design fires and define what is the role of the analysis units, which is this compact and very efficient type of unit. When the fire is happening in real time, what we can analyze and what we have now is we can find and define which are those trigger points that can be predefined before, if we know our past fire history, to try to define our potentials. Okay, and some of you have been talking, have you been listening? Mark's what is a potential of a fire, all of them are defined by those trigger points in the terrain. Those can be defined. You can harvest that local weather because that observation capabilities. You can also take a look and really track the situation of the vegetation. We have not only the MODIS, which is a fantastic observation instrument. We have 15 years of continuous observation of our vegetation all over the world. We did the field model that we did for the Marines, for Camp Pendleton and for Castilla-La Mancha, is based on 15 years of analysis of the phenology of the vegetation. And you can track today what's the stress of vegetation based on 15 years of history. And that is also can be pre-calculated there. And also you can see the fire behavior. To support that, we have developed the simulation modes like the propagation, the adjustment, probabilistic, all of that. Those are tools that are on that table that could be spread into that situation unit table. And of the units, the crews, we can track the location. That's something that happens here in Spain. And when I first went to the US and I saw that most of the fires were being battled without tracking the units on the terrain, I was like, what? GPS is right now 30 years old. Facing fires without tracking the units on the field, for me, is unacceptable. And it's unacceptable by the society, okay? And the technology is there. It's about tools. So tracking the location of the units, tracking the real performance. When we're facing a fire and we're sending those units and with an expected capability, that capability could be measured for what they did in the past, and we can track that performance. And of course, tracking their exposure to risk. If there's going to be a change in the conditions, you're going to be able to inform them, okay, guys, you are here, you don't have the awareness, the situational awareness of what's going on, but I can give it to you. We have to redefine the safety officer position and the situation unit. That's my biggest point. And then support the tactical decisions with the real-time adjustment of what the fire is going to do, with operational weather coming from the field, and try to find the changes in the conditions that are going to create a risky situation, or the windows of opportunity to put our operations in place, okay? And that's where the mobility mode takes place. So I had some examples of my points here, all the design fires that were the techniques that were defined by Mark, the strategic support of our units, what is being done by the Chileans right now, okay? And the tracking units right now in Castilla-La Mancha, we're tracking the units on the fly with these satellite devices, also in Texas, in Georgia. And about how we can advance our simulations and support what are the decisions of a firefighter to get to a safety zone, we have created a methodology and a model that I'm going to show right now. Okay, it's a long presentation, so I'm going to just go into the mobility mode. Okay, when the situation goes wrong, we have to be able to answer when we have to go, where to go, and which way to go, okay? There are some models. There is an envelope model that was created by Tobler that gives you the time for a crew, for somebody walking on the field based on vegetation and slope. We analyzed that model with the tracks coming from the open street maps. We analyzed like 100,000 tracks that people that put it over there. And it's a pretty good envelope model. We had some Run for Your Life models that were in the paper for Matthew Alexander and Brett Butler for the different extreme scenarios that they were analyzing on the Man Gulch. That is not the one that we're facing right now, okay? So the one that we have created, basically, I think I'm gonna show it to you right now, is, okay. So if it's working here, that's the safety app. Okay, and now I'm going to show you a real life. Okay, so these are the units on the field. These units, it's a real incident. That's the Lietor fire. So the units are being tracked on the field right now. The fires, the simulation is there. And what we can say in 1 second is what's the time for a unit to reach to every point of the incident. I don't know if you can see it here. Okay. So I have the unit being tracked, and these areas are 15 minutes, 30 minutes, 60 minutes, 90 minutes to get to that point. And oh, this is the real one. So here I have the time. So these are the real units coming on the field. And now one crew is going to appear, the fire is right there, I'm gonna stop it. This is the tactical environment. You need a 4-dimensional, yeah. So I'm gonna click on that crew. I just click here, and it's gonna calculate the time to arrive to those safety zones. And hopefully it's gonna show it to you right now. So this being captured by the CAD. You can go in first-person view in all of them. You can do the modeling. You can include the weather, okay? And then you can show those times. And I have like 15 seconds. I don't know if I broke it. Probably yes, but that's fine. No, yes. Okay, we can, no, it's here. So here, what I just calculated right now is the time, the different paths, optimum paths for the crew to go to a safety zone or to wherever. We can apply this model. This model is called mobility. We can include any kind of variable, and we can apply to dosers to tell, okay, what's the time for a doser to make this line? Or what's the time for a crew, 2 crews or 3 crews? Right now, we're working on the mobile app, so this model can be adjusted to the real speed of the crew in the real performance that they are having, okay? So basically, that was it. That was fast. And of course, I wasn't ready for talking that much. But anyways, if you have any questions, I'll try to answer. My point is basically we need to redefine that situation unit. And right now, what I see in my experience of what I've seen in the big fires that I've been in America, where the teams are deployed, a lot of focus on creating fire maps, a lot of focus on safety procedures, but honestly, we're facing fires that are running like the one in Las Máquinas in Chile, 120,000 hectares in one day. Or the fires that we have here in the Mediterranean in Southern California, they have a terrible rate of spread. And honestly, we have to empower from that situation unit to the people on the field with this kind of analysis in a very, very simple and efficient way, okay? If you guys want to know more, we'll be there with all the same thing. Thank you very much, and I will be glad to answer any question. Thanks.